I think what we've learned from Naviaux's work and others is that the mitochondria have the ability to sense the energy flow through a cell. And there's a certain amount of energy that we need for the cell to run smoothly. And when there's a drop in energy, it's like somebody flicked the smoke detector or the fire alarm in the factory, right? And so, whoa, there's a problem here. And now all of a sudden, instead of making widgets, we're going to shift to getting anybody who's not important out of here, and everybody else is going to be focused on trying to find a threat and put out if it's a fire, right? And I think what we're learning about the mitochondria, and for anybody who's listening to this, we know probably this much of what we think we know this much, and we really probably know this much. So all the stuff we say, we're simplifying and dumbing it down, but the mitochondria seem to have ability to sense energy flow. And when they sense that there's a drop in energy flow, that can initiate the change in physiology from manufacturing, making peptides and proteins and hormones and all these other things, to saying, hey, there's some type of energy, something stealing energy here. It's a potential threat. And let's shift to defense mode, slow down the manufacturing and start into defense mode.
Hey, this is Ari. Welcome back to the Energy Blueprint podcast. In today's episode, I am featuring a mashup of 3 past guests all about the cell danger response, the CDR. This is a deep dive into mitochondria and a critical piece of the story of how they function and how they control human health more broadly. This is something that you've probably heard me talk a lot about. The cell danger response is very central to my paradigm of human health, what controls energy levels, what controls disease, and I think it should be at the center of everyone's paradigm. I think this is a really critical piece of the story of how to understand human health properly. And, there are, if we look at human health, it's, if we look at a car, let's say an engine of a car and all the different pieces of a car, even within the engine, there's the pistons and the crankshafts and the spark plugs. And, there's, if you look at a car, there's many, many different pieces, dozens of different pieces that if you were to remove them, that car would not function properly. Things that are necessary for the car to function. The human body is very much the same way in that sense. There's every piece of the human body is important in some way. And if you were to remove it, and certain rare genetic abnormality, sometimes you see these kinds of things, you remove some random little thing and then you get big health problems. Everything there is there for a reason, and it's all important. Yet we also need to have some sense of what is most upstream. What is the thing that is controlling and regulating lots of other things going on in the body? And that's where the story of mitochondria and the cell danger response is really important. Dr. Robert Naviaux, who happens to be one of the 3 guests in this episode, is the, let's say, the pioneer, the I don't want to say the founder, the person who first coined the term, the cell danger response, which has since been enormously influential within medicine, especially within functional medicine. And he describes mitochondria as the central hub of the wheel of metabolism. And that gets at this idea that I was just trying to describe here, which is, yeah, there's hundreds, thousands of things that we could say that are going on in the body that are important in some way. You can do a blood test and measure dozens, or now with some of the more modern blood tests, hundreds of different biomarkers. You can do other fancy testing, microbiome testing, organic acid testing, saliva testing, all kinds of testing. You can get hundreds or thousands of data points on things going on in your body. But we need to have some idea of how to prioritize what's most important based on an understanding of physiology. What are the key pieces of physiology that are most upstream, that have the biggest impact on regulating and controlling everything else, or lots of other things going on in the body? And If you've heard me talk about this before, you know that in my paradigm of health, mitochondria are, like in Dr. Naviaux's paradigm, very much at the center of it all. So with no further ado, you're going to hear from 3 different experts on the cell danger response and on mitochondria, on this critical piece of the story of human health and energy and longevity and disease prevention. Those 3 experts are Dr. Eric Balcavage, who is a brilliant expert, world-renowned thyroid health expert who puts mitochondrial health very much at the center of understanding thyroid dysregulation. You're going to hear from Dr. Eric Gordon, who is another brilliant mind who specializes in chronic complex illnesses, mysterious illnesses, the kind of thing that, people have these weird symptoms, weird condition that they've gone to 30 different experts all over the world for a decade. Nobody can figure it out. They go to Eric Gordon to figure things out and to try to make progress. And he's a very, very eccentric guy. I always love my conversations with him, as I do with Dr. Balcavage as well, because he thinks very differently. He's thinking in new ways, in novel ways, thinking outside the box. And I always find it refreshing and enlightening to have conversations with him. So I think you'll enjoy him talking about mitochondria and the CDR and how he conceptualizes all of that. And as I said before, you're also going to hear from Dr. Robert Naviaux himself, who is the physician researcher, MD, PhD, who runs a lab for mitochondrial medicine at the University of California, San Diego, someone who I've had the pleasure of visiting in person at their lab and getting, let's say, sort of a private teaching session with him at his lab, which was an enormous pleasure and honor for me. Obviously, goes without saying, he's a brilliant mind. He's the one who coined this term and put the original concept of the cell danger response together, piecing together a huge body of literature that has been emerged for that has been sort of being compiled by researchers all over the world for many, many decades. He put the pieces together to sort of make sense of things, of what mitochondria are actually doing beyond just sort of taking in carbs and fats and pumping out energy, pumping out ATP, but to really reframe our understanding of mitochondria in this new way as something more than just mindless energy generators. And he is the one who created the cell danger response as a concept and he's now published several papers on this, and this has been hugely influential in the field of medicine. So I've got him on the podcast as well. So with no further ado, enjoy this mashup episode with these 3 wonderful and brilliant guests.
The cell danger response is something that Dr. Naviaux gave it its name. I don't think he loves it anymore, but he's kind of stuck with it. But the thing I want the first thing people have to understand about it is it's just a story. It's a framework for understanding how our body works. The reason I emphasize that, I've spoken about this in medical, symposium here and there, meetings, and people come up to me and ask me afterwards, is this the CDR? When they're having a patient, and it's like, I guess I'm not very good at explaining it, because the point is the cell danger response is the immune response that's choreographed by your mitochondria. That's how you defend yourself against all threat. It doesn't matter if it's an angry neighbor or if it's a bullet or a bug. This is just your body orchestrates a response. And Dr. Naviaux has called that the cell danger response, and he has stuck the mitochondria in the middle of it. And I always want to remind people is that I'm sure that other smart people will find other organelles that they can say this one is in the middle of it. But I happen to find his way of looking at it very, very helpful, because it's the old story. Who's the most essential organ? The brain or the rectum, and if the rectum stops working, the brain doesn't do so well. It's a circle. Yeah. We need it all.
Sure.
So but still, the mitochondria, produces energy, but it also senses the electron flow and the raw material flow in the cell. And by sensing it, it decides when things are safe and when things are not safe. It signals the whole body. And so so where are we going with this? Why? It's just that if when you start looking at this, at the body as a system, as a network of information and flow, you can, and when somebody tells you you have long COVID, or when somebody tells you you've got chronic Lyme, or you have mast cell disease, or you've got whatever the flavor, parasite, whatever the flavor of the month or the year is, because these things wax and wane. When I started, everything was Candida, and then it was all parasites, and then it was all Lyme, and then it was all Bartonella, and then Babesia, or Babesia Bartonella, I forget which, and and then it was all with hypercoagulability and mast cells and mold. I mean, it's everything. It just depends on your sensitivity and your exposure. Okay, so don't get hung up and don't look at lists of symptoms on the internet and decide you've got Bartonella. Because as I say, one man's Bartonella list is another man's Babesia list. Anyway, but beginning to understand that when you're chronically ill, okay, and I guess people should include in chronically ill things that we consider, well, they are chronic illness, but people sometimes forget that when you have, that when you're chronically ill, you're chronically inflamed. I guess that's my point. Okay. Chronic illness is chronic inflammation. Okay. And what people don't get is that it also includes, like, insulin resistance is chronic inflammation. Hypertension is chronic inflammation. Renal disease is chronic inflammation. It's it's just what happens when your body tries to protect itself and then can't stop. Okay, and I always compare this to psychology, because again, psychology is just a more alive model. I mean, Chinese medicine is actually a much more alive model than our current medical model, because it's alive. It understands balance. Medicine tends to do black and white. So when your mitochondria sense something is off, okay, they go through a pattern. Now, they go through a similar pattern every night or every day in something we call the health cycle, where you break down some tissue, you build up, and so your mitochondria are signaling that this cell is kind of sick, or that the mitochondria will break apart and will then decide if they're going to survive. If they decide to die, the cell decides to die. It's good, you repair it, but the repair mechanism is minor. The cell, what we call the healing cycle, is when you need the contractor. The health cycle is what you do every day. You can, like, fix the hole in the wall, with a nail hole or something, with a, maybe you can. I used to be able to, but so what the constant daily repair that we go through is the health cycle. But when we get injured, we go into the healing cycle, and that is where people get stuck. Okay, I guess I'm making the point is that leads to chronic inflammation, because your mitochondria get stuck either in the first step, where they're not really producing energy at all, they're just producing ATP as a signaling molecule. Okay, and your cells are burning glucose at that point, and that's why a lot of people who are really sick feel better when they eat sugar or simple carbs, because that's what they're burning. In order to really burn fat, your mitochondria have to be working. So if your mitochondria are kind of browned out, they're busy making a little bit of ATP, but they're using that as a signaling molecule rather than as an energy production molecule. you're going to be tired, because that's what Dr. Naviaux used to call, I still like it, the CDR1, the first step. That's the first step in injury. You get cut, you get an local infection, you call in your innate immune systems, but the cells are busy killing a bug that's in the inside or binding up a toxin. And when they're doing that, they're not busy making more of themselves. So the mitochondria stop making energy, which creates high oxygen tension inside the cell. Because that's another little detail, I don't know what, is that the mitochondria are the part of your cell that uses oxygen. Because not much else in the body really uses the oxygen in any significant level, okay? But the mitochondria use oxygen and make water out of it. They add hydrogen and they make water. You know, when they finish making ATP, or just before they finish the last step, you know, so when they stop doing that, the oxygen concentration inside the cell rises, which creates oxidative stress, which is what your body is using. And Dr. Naviaux likes to call that oxidative shielding, because that's the first step in killing those viruses. You know, this is a self-protective mechanism. But if you don't shut that down within a day or two or three, then you've got chronic oxidative stress going on in your body. See, and you know, you have other mechanisms to create plenty of oxidative stress. It's not the only one, but this turns it on. But when that's what it should happen, is that then the nucleus, seeing the higher oxidative stress, starts pouring out chemicals that are antioxidants. And that's probably one of the reasons a lot of the herbs, which are many of them are pro-oxidants, many you know, things like artemisinin, I mean, many of them are pro-oxidants, but they work because they stimulate the antioxidant response of the body. So you have this, so that's the CDR1, which usually should be short-lived. This is calling, and this is also where your innate immune system, you know, the neutrophils and the macrophages are coming in. That's that first, like thinking of COVID again, that's that first week that should be happening in the first week of COVID. Unfortunately, COVID is smart enough to screw up that system in the beginning and get it to be out of balance. So CDR1 is this inflammatory time. During this time, you're going to have what we call sickness behavior. Sickness behavior is you're tired, you're irritable, you don't want to eat, you want to be left alone, you often have a low-grade fever, you know, because, you know, it's self-protective. If you live with a bunch of people and you're getting sick and you're going to be hanging out and spewing all around them, it's not healthy. I mean, it's not about masks, but, you know, we do spread respiratory pathogens by breathing and talking. Anyway, so that's the CDR1. The CDR2 is when you're starting to heal. Okay, now you have to rebuild some of that damaged tissue. And so at this point, the mitochondria, what's interesting, they're still not making a lot of ATP, but they're making a bunch more, but they're using a lot of their energy to produce building blocks for the cell, you know, bigger, you know, things that will make RNA and DNA and the building blocks. Okay, and your cells are still burning sugar. And again, this is a level that we often see in people with hypertension are stuck here, people with insulin resistance. They often have places in their body, because that's the other thing that I want to emphasize, is the CDR is a local phenomenon. It's rarely happening throughout your whole body at the same time. You know, usually it's wherever there is the insult. You know, if it's the whole body, people usually die. It's called sepsis. You know, all the organs are screwed up.
Well, maybe there's some in between territory, right? Because let's say you have a local injury to a specific part of your body, then you have a local CDR reaction, but you don't necessarily get systemic symptoms from that. But part of the CDR, as I understand it, is the systemic level signaling of purinergic molecules, you know, some of these energy molecules that are circulating that are causing systemic symptoms, whether those symptoms might be present in the case of autism or in the case of chronic fatigue syndrome.
Absolutely. Yeah, it's the signaling that becomes systemic.
Yes.
Absolutely. Yeah, right. The local, you can have like 5 or 10% of your liver is inflamed. You know, I mean, like that's what we often see. You know, people with cirrhosis, they have like little patches to start with because there's only some cells that are stuck in that CDR2 place where they're building tissue and they're not really communicating well with its tissues around them. Yeah, but they release chemicals. I mean, that's the whole thing about, you know, senescence, maybe is the senescent signaling molecules that these cells that are stuck in various places in your body, in CDR1, CDR2, or even in CDR3. And let me just go run through those real quick, because the details of the CDR, it's just the idea that there's stages. So one is this acute inflammatory stage, two is this rebuilding stage, okay? But the reason I'm emphasizing the glucose metabolism is because this is like cancer cells. When cells become cancerous, they're using what we call Warburg metabolism, which people thought was like causing cancer. No, it's what the mitochondria do when you're having cells that are rapidly reproducing. they are busy making the building blocks, and the cell is using glucose to make energy, you know, and the mitochondria are not producing, are not using up as much oxygen. So they always thought that the mitochondria was disordered. I guess that's one of the important pieces of this long story is that except for maybe, I think there's like 400 known mitochondrial diseases, which are all extremely rare, okay? And most people who have them die when they're young. The vast majority of people have normal mitochondria. You know, again, we are now going to the molecular level, so people are doing mitochondrial genomics on like people who are mild, and yeah, you can find that there's the SNP for like the first cytochrome. That's a big one. People are finding the first complex one in the electron transport chain, and you can have some SNP so you don't bind NAD that well, but you know that alone does not make you sick. Mm-hmm. Okay, that's like it. When you're sick, that can make it worse. And it's cool to find out that is because sometimes those people do respond to a little more NAD, which is kind of cool. But the point is that that's not. But you're not sick because of that SNP. You know, we just happened to find it because we were looking for it. So anyway, so that's CDR2 is this building. You know, and that's where stem cells are being called in and all kinds of good things are happening. CDR3 is when these newly built cells are learning to communicate with their neighbors. Mm. Okay, and that's when the cell receptors, because remember in CDR1, one of the first things that happens is the cell membrane kind of hardens. Okay, you've got all those nice lipids, okay, with proteins in between them, and those proteins change shape and the lipids change configuration. And and the cell membrane itself becomes less permeable, and it also stops taking in the signals. Okay, and this goes into my basic theme about how to help people get well is you have to restore communication throughout the system. Mm-hmm. Okay, and CDR3 is about that in a big way because that's when the cell is learning that, hey, I'm a liver cell and I have to communicate with these guys around me. And I have to send out the right signals to the rest of the body. And I'm now going to start listening to the thyroid hormones and the adrenal hormones and all that soup of information the cell is going to start listening to. Because what you have when you have senescent cells, they're not listening to the information as clearly. And they're sending out old signals, they're sending out signals that would be appropriate if you're trying to still fight something. Mm-hmm. And unfortunately, when we keep doing that as we get older, we get creakier. You know,
so in that way of speaking, there, you're likening senescent cells to being in CDR, being stuck in CDR, in the CDR.
Exactly. 1, 2, or 3. It doesn't matter which one. They're senescent cells because they're releasing proteins and exosomes. Because exosomes, not just the mRNA vaccine, but exosomes are one of the major ways that we're just discovering that your body communicates. And they're like little lipids with proteins stuck in the middle, okay? And when your cell gets sick, it starts spewing out these exosomes as communication molecules. And it keeps doing it. It's just one of the ways we communicate that they're just beginning to get. When 20 years ago, people thought exosomes were kind of like cellular debris or, you know, like were just nothing. They didn't know what they were. Welcome to junk, junk like junk DNA, oops. there's very little junk in the system. We just don't understand it. So anyway, so these, so when a cell is not operating back to the mature interactive cell in the community, when it's stuck in any phase of this self-protective response, it is sending out danger signals to the body. Now, again, luckily we are an incredibly redundant system, because every time you read about what's wrong with the body and you start going into details, you think, oh my God, I'm going to die because, I got this or I got that. And somehow we manage to keep going. Your C-reactive protein is 6. Oh my God, you're going to have a heart attack tomorrow. No. I know plenty of people in their 80s with CRPs that are high and they survive. It's we get too hung up on these numbers, like they're the only signals we know how to read so far, but they're signals out of billions of signals. We have to remember that. When people get really scared when they get an abnormal blood test, and sometimes it should, sometimes it is bad, but lots of times it's just, we should do something, but you're not going to die from it. The system is incredibly redundant and resilient. So that's the CDR 1, 2, and 3. And I knew you wanted to make another point, so I'll shut up. Okay.
So let me ask you this. So the CDR, it's worth saying, is performing a positive role as well in facilitating our survival in response to stress, in response to cellular damage, cellular threats, danger. It is an intelligent, adaptive response to respond to things that threaten us. Now,
well, a thing I want to make is that it's just how your body communicates. That's what's so funny, is because he's identified the CDR is when, like I said, when something is really broken, but you're using that same system at a gentler level every day. Exactly. Every time you go to sleep, your body is going through these healing cycles. And that was my clumsy analogy about, fixing something simple at home. That's that's what you're doing every day.
And during hormetic stress as well, and during exercise, during cold exposure, during heat exposure, during breath holding practices, we are engaging it. We are essentially training it, and I would say resetting the system. And I think Dr. Naviaux, I've spoken to him in person. I had the privilege a few years back of going to his lab for mitochondrial medicine at the University of California, San Diego, having a little private session with him. And I spoke to him about hormetic stress, and he hasn't said much about it publicly, but he lit up when I started speaking to him about that, because he knew it's like pressing the reset button on the system.
It's training. It's training your system. I'm sorry. That's Bob lights up. That's what makes him fun. You give him an idea, he goes, but that's it. It's because we need to keep in training, and that's why when you're a couch potato and you get hurt, it's so hard. It hurts because the system is creaky. It hasn't been practiced. You need to keep it going. It's a system. That's what I think where I'm so glad that you emphasize that this is nothing wrong, nothing broken. It's how your body works. The problem is when the signal isn't modulated correctly, and that's because some other thing isn't, you're either lacking a nutrient, maybe an immune cell has gotten out of whack.
That's the question I wanted to segue into, is the system can get stuck. We're supposed to be able to sort of oscillate between going into the CDR when we need it and then coming out of it and restoring sort of, as Dr. Naviaux calls it, peacetime metabolism. Mitochondria are now shifting into, I call it energy mode. They're pumping out lots of energy, and we're no longer in wartime metabolism trying to defend against threats. But the problem is sometimes the CDR can get stuck in wartime metabolism. So explain why that is. What is, and you do a lot of work on chronic Lyme disease, long COVID is a big focus of yours now. Obviously, I think this aspect that we're talking about here, as far as the CDR getting stuck, the body getting stuck, the mitochondria getting stuck in wartime metabolism, is a big part of these chronic illnesses. So what is happening there in terms of your paradigm?
Is that since this is a communication system, okay, and I'm sure there are multiple levels of it, but simplistically in my head, I usually focus on the immune system. Okay. And immune cells, by the way, also change, their mitochondria change just the same way, as an aside, but let's not go, I won't say more about that. But so I look at the immune system because it's like, you know, you look at, well, long COVID is a great example. Okay, is that who got really sick, who died, and who got long COVID. Many people thought they were healthy before they got sick, but usually when we dig down, we find that there was underlying insulin resistance, a old infection that their body, like an Epstein-Barr, like all of us have Epstein-Barr almost, but some of us are not, we have excessive amounts of B cells that still that have the EBV, the Epstein-Barr virus, living in there. You know, senescent, you know, quiet, not reproducing, but every time that B cell reproduces, it can reproduce, and when it does, or you can reproduce a piece of it, and that can spark your immune system. So people live with that. And they don't notice it. They're just people that maybe, like, if they like work too hard and they exercise too hard and they, you know, party too much, the next day they might really feel like crap and take 2 days to recover. You know, but they just thought, it was nothing, you know. But their immune system is always a little bit more amped up than normal. Okay. And so when they get sick, their immune system is already kind of on high alert, and it doesn't know how to go through the process of quieting itself down. Because you see, you know, another circle. People talk about the innate immune system and the you know, like the macrophages and neutrophils and the T cells and the B cells, like everybody's got, and the NK cells, like everybody's got separate jobs. Okay, and they do on a gross level, but on the communication levels, if the neutrophils don't work right, don't send out the right signals, the macrophages don't work right, the macrophages don't work right, they don't give the T cells the right signals, and so the T regulatory and T helper signals don't work right. You know, they all work because the system is so redundant, but the thing is that it has to work really well to get well. You know, to simmer this, to let it, you know, it's to let everybody know that the war is over. You have to have a good communication system. You know, if you've got, you know, soldiers who are, you know, like in a like the Japanese soldier who they found, like, you know, the old story, the guy who was still fighting in the jungle like 40 years after the war ended because nobody told him. Okay, you know, well, that happens in your body. Okay, the communication drops a little bit. So this chronic, so what I find is that usually there's a toxin exposures that your body couldn't deal with. And just another quick aside for people, it's usually not the level of the toxic exposure, it's just your sensitivity to it. Because Dr. Naviaux looked at, he hasn't published it yet, but he looked at like 1,200 toxins in about 1,000 people. And the difference between the sick people and the healthy people, there really wasn't. Okay, really? In the quantity. Because, I mean, again, there's always the exception. If you get enough of something, you're going to eventually get sick. But we're talking about the levels that the government would like us to think is safe, you know, because it's too complicated to realize how they're not.
So if it's not objectively differences in the degree of exposure, let's say the amount of virus that's present, the amount of Epstein-Barr virus that's in a person's system, the amount of mold toxins, the amount of other chemicals or heavy metals or something, then it has to be the individual's susceptibility to that, or ability to be resistant to that stressor. Is that
Yeah.
correct? Or
Yeah,
what,
it's
what else?
biochemical individuality. We are different. There are people who used to be able to work in battery factories that had incredible lead exposures, you know, in the 50s. I mean, like, you know, the lead levels that was considered acceptable, at least I remember by the 70s, they were down to 80. Now we know they should be down to nothing or 1, you know, I mean, like, you know, microgram per liter. I mean, it's just, we didn't know. So the point is, but there were lots of people who worked in those factories who felt fine. And there are other people who walk in and worked for a day and went home and felt sick and had headaches.
Uh-huh.
You know, yeah. So the difference in what we can, I mean, I can eat anything. You know, people I live with, like if the food's out for a day, you'll give them a bellyache. I can eat stuff that's been sitting out for a week. We're all different. You know, I mean, ApoE4 is probably good for something. We don't get infections. We might get, you know, I mean, so that's what people have to understand. I always say is that we are alike. We all respond pretty much the same way to a bullet, but to a feeling, we all respond very differently. And to a bug, you know, I mean, because 50% of people who had, I mean, they said something like in the beginning, 50% of people with COVID were asymptomatic.
Yeah.
You know, so it's clear that it's us. And so the reason that people get stuck in CDR 1, 2, and 3 can be very variable. And one of the things that we were going to tie in, and I'm going to reach for it, is structure. Okay.
Yes.
Nobody talks about structure. One of the things that I see as a regular doctor is that people come in and nobody paid attention to how tight, how stuck, how things, you know, like, you know, they all, you know, you might have chronic fatigue, but if your body isn't communicating with your left arm, you know, because you had an old injury that never healed, well, that's going to get in the way of your healing because the blood flow is not going to be good there.
Can you describe, for people who are unfamiliar with it, what the cell danger response is and why you believe it's central to understanding chronic fatigue and many other diseases?
Yeah, sure. The cell danger response is an evolutionarily conserved universal biologic response to environmental stress, threat, infection, or injury. And, you know, it's a normal and reflexive part of life. We need it to learn and adapt. We need it, you know, to give gains after exercise. We also need it to fight infections and heal from injuries and to heal from psychological traumas. So the CDR starts by sensing stress or injury in mitochondria in the cell. And if the threat is slight, like a paper cut or a scrape or a common cold, the CDR is confined to those affected tissues. And if the injury or threat to life is large or infection is severe, as with a heart attack or stroke, Lyme disease, or a SARS-CoV-2 infection, for example, mitochondria and cells trigger a multi-system and multi-layered response that ultimately involves both the brain and body. So, you know, our research has given us a glimpse of, you know, a connection between many chronic illnesses. And when we performed metabolomic analysis of over a dozen different complex disorders, ranging from primary mitochondrial diseases through autism spectrum disorder, myalgic encephalomyopathy, and chronic fatigue syndrome, Gulf War illness, depression, suicide ideation, and ALS, we found that the pathways that were dysregulated by the cell danger response are a common denominator in each. And since we know that genes and environmental risk factors that cause these disorders are actually different in different patients with the same disease, it got us thinking that it's not the specific pathogenic trigger that creates a specific disease. Instead, it is each chronic disorder is caused by a single shared biological response to over hundreds of different pathogenic triggers. And this common biological response we call the CDR.
What can I ask you, what are some of those triggers?
Well, some of those triggers are, you know, a Borrelia infection in Lyme, an EBV infection, SARS-CoV-2 infection. It can be hazardous volatile organic compounds in in the workplace. It can be a head trauma. It can be, just anything that causes a stress outside of the normal range of homeostasis ends up triggering, the cell danger response to greater and lesser degrees.
Mm-hmm.
So, when we started thinking about this, we needed to find a way of integrating, all the strong work that has already occurred that uses what we call the pathogenesis paradigm. And we began to think of causes of disease in two classes. And many different genes and environmental factors can lead to a disease like autism spectrum disorder or, amyotrophic lateral sclerosis, ALS. Yet each disorder can be diagnosed by, specific core symptoms. So the causes are different in each patient, but the core symptoms are the same. This led us, to think about this concept of penultimate and ultimate causes. And so the study of penultimate, causes of illness is well known. That is the study of pathogenesis. Pathogenesis is a study of different genes and environmental factors that initiate the injury, trigger the CDR, and start the entry into the healing cycle. In contrast, the study of ultimate causes is the study of the shared biologic response that's used to exit from the dynamic process that maintains chronic illness. That's the study of salogenesis. Pathogenesis creates the injury. Salogenesis affects the repairs. These are distinct pathways, and it's important to remember that the path to healing cannot be traveled by retracing the path that led to the illness.
Can you elaborate on that? What you mean about that last part, that the path to healing is not just the simple reversal of the path to illness?
Yeah, so for example, if we develop a pneumococcal pneumonia, we have a bacterial infection of the lung that can be treated with antibiotics that can eradicate the bacterium. But then there's a lot of damage that's done to the to the lung tissue that has to be repaired. And actually, the removing of the bacterium is just the first step, but energy and resources from the body have to be redirected toward rebuilding all the broken alveoli and the blood vessels and to reestablish the architecture of the lung. So yeah, just knowing, yeah, so that's one example. And we could talk about head traumas and traumatic brain injuries. Frequently when an injury has occurred, it has this long-lasting effect that's just knowing what the original cause was doesn't actually help you to resolve the chronic symptoms.
Mm-hmm. So you said the ultimate causes of disease, you described it as things that, I'm sort of paraphrasing here, but things that prevent salugenesis, things that block the healing cycle.
Yes.
What's going on there? How would you describe that, or what kinds of things prevent the body from entering the healing cycle or completing it?
Well, sometimes it can be a secondary infection. Sometimes it's helpful to think of these in the simplest terms. So if you have a cut and it's partially healed, but then you stretch it over a hand and break it open again, the healing process has to go back to the beginning. It has to start again. It can't just pick up where it left off. Same thing if you remove a scab from a scraped knee. It goes back to the beginning. The same thing happens, and it's actually been measured in the crashes in chronic fatigue syndrome, is that you can, go from one state of metabolism to a state that's more dependent on glycolysis and more inflammatory, that's, after a crash, that then requires you to make your way back to your baseline after the crash. So I guess the important thing to remember is that re-injury can, keep you in the healing cycle. But sometimes what happens is the cells that initiated the signals of danger and threat that triggered the initial cell danger response, and the brain that is responding to sensory information sent from those cells, haven't yet been convinced that the world is safe enough to heal yet, and so it keeps the signals going that maintain defense, even when the actual triggers are in fact gone.
I know I sent you a list of questions I wanted to ask you for this interview prior to it. I want to jump a little bit ahead because I feel it's a natural segue with where we're at in this conversation. So just going further on salugenesis, do you feel that this concept that you're describing, as far as the healing cycle, has been incorporated or properly incorporated into the conventional medical paradigm, the Western medical paradigm?
Not at all. In fact, our training in the scientific method and in Western medicine has really focused on the things that have been successful up to now, which is, in Western thinking, typically isolate a single variable in doing your experiments, and listen with your experiments, ask a question of nature, and then listen to the results and design a new experiment. That's very effective when a disease or process is regulated by single things. Okay. But what we find in the vast majority of chronic illness is that they're pluricausal. That means, that's a term that was used by Hans Selye. That basically means that, for example, you can take a disorder like ALS, and you can have an SOD mutation that can lead to it. You can have a TDP43 mutation that can lead to it. They almost never happen in the same patient. These are just different things, different ways to get to the same, the same problem. And so ultimately, so we've been taught to think about diseases in a way that has been effective in the past, but is not very effective at understanding dynamical processes. Okay, so and a lot of our inspiration not only comes from fields of ecology and evolutionary biology, and so that led to us thinking about salugenesis as a dynamic process that has regulators that can drive outcomes in one direction or another, but are not on and off switches. Okay, and so what I think of salugenesis as a multi-layered process that starts with mitochondria and cellular changes that ultimately can grow to change whole body behavior and metabolism. Mm-hmm. And the autonomic and endocrine systems and the microbiome are always engaged, when the CDR is activated. But because salugenesis, healing is energy and resource consuming, you have to actually take materials to heal a broken bone or to recover, from a heart attack, for example. That you can't restore full and vibrant health without being able to redirect those energy and resources away from cell defense and back to normal cellular functions.
Mm-hmm.
So I guess, yeah, so that kind of leads to this natural idea that, we talk about pathogenesis-based approaches to medicine. That's filling this book that has been, we've been writing for the past 5,000 years of written history that, I call the first book of medicine, that really is based on the pathogenesis paradigm. It has been very, very effective for, many acute disorders. But I believe that to discover effective treatments for chronic illness, we need a new paradigm and a new way to do medical research for discovery. Mm-hmm. And I think that study of salogenesis-based treatments and the process of the molecular process of healing will help write the pages of a second book of medicine.
What is defense mode, and what role do the mitochondria have in that? Because as most people are taught in their high school and college and graduate school and medical school biology classes, basically mitochondria, what people know is they're the powerhouse of the cell, and most people's knowledge stops there. And in graduate school and medical school, it's like it goes a little bit further, and basically they'll teach you a story that mitochondria are one of many different organelles in the cell, but they're basically framed as these sort of mindless energy generators that just take in carbs and fats and pump out ATP. And what you're alluding to here, very much like my work, heavily influenced by Dr. Robert Naviaux and the cell danger response, is that mitochondria are way more important than we ever learned in biology and physiology courses in our formal educations.
Yeah, I think what we've learned from Naviaux's work and others is that the mitochondria have the ability to sense the energy flow through a cell. And there's a certain amount of energy that we need for the cell to run smoothly. And when there's a drop in energy, it's like somebody flicked the smoke detector or fire alarm in the factory. Right. And so, whoa, there's a problem here. And now all of a sudden, instead of making widgets, we're going to shift to getting anybody who's not important out of here. And everybody else is going to be focused on trying to find a threat and put out if it's a fire. Right. And I think what we're learning about the mitochondria, and, for anybody who's listening to this, we know probably this much of what we think we know this much, and we really probably know this much. So all the stuff we say, we're simplifying and dumbing it down. But the mitochondria seem to have ability to sense energy flow. And when they sense that there's a drop in energy flow, that can initiate the change in physiology from manufacturing, making peptides and proteins and hormones and all these other things, to saying, hey, there's some type of energy, something's stealing energy here. It's a potential threat. And let's shift to defense mode, slow down the manufacturing and start into defense mode. And Naviaux in his paper talks about a whole bunch of different steps to that cell danger physiology and that process, and reducing mitochondrial numbers and function is a large part of a protective cell danger response. And people might consider, why would that be a protective response? If you're taking the thing that's actually generating energy, how could it possibly be that having fewer of those is better? And the reason for that, at least in what we believe right now, is that when we have cells that are in this state of low stress, what we call homeostasis or manufacturing mode, those cells are bringing glucose and fats and other resources into the cell. They're jamming them into the mitochondria to be converted through the Krebs cycle and something called the electron transport chain to turn food energy into cellular energy. And the process of that is awesome, especially when we have oxygen to drive the process, because we could take one glucose molecule and make 36 ATP, which is cellular energy units. So we get a great return on our investment. And any excess we can drive off as heat and create a little some other side effects that are beneficial to the cell. The cell, that process of going through that Krebs cycle, electron transport chain, making that cellular energy results in a little bit of exhaust. Just like driving your car, you're still driving a gas car, is going to create a little bit of exhaust. And so that sounds bad. Like I'm making some waste that comes out. Yep, you're making some exhaust. We call those free radicals. Well, that doesn't sound good. Well, the good news is the cell also makes, as with many things in cellular physiology, for the free radicals we make, we also have a system inside the cell that makes antioxidants, things to kind of balance out those free radicals that are being generated so that we don't damage the cell as part of the process of making cellular energy. So that's how it should work in a low stress state. But one of the defense mechanisms to find a threat, it's a bacteria, a virus, an organism, is to ramp up some of those free radicals and ramp up inflammatory chemicals, which could damage the cell if they were excessive, but they're also part of the tools that we use to deal with the threat. So the cellular intelligence is pretty smart. If I have all the exhaust that I'm making through this regular mitochondrial function, plus I have more free radicals that are being generated as part of my defense response, I have way more free radicals being generated, and I have the ability to make antioxidants. And so if I don't do something, I either have to make more antioxidants or I need to decrease the free radicals. Otherwise, we have excessive free radical formation. We call that oxidative stress, and that's what creates damage and destruction to the cell. And cellular intelligence is just smarter than that. So what it does is it says, hey, what's the more important thing here? Making cellular energy or defending myself? Defending myself. So what am I going to do? I'm going to downregulate the mitochondria. I'll make less cellular energy, but I'll also make less exhaust. Then I can use those antioxidants to deal with the fallout from this defense mechanism without causing damage and destruction to the cell. My opinion, based on some of the science.
So you said earlier, I loved when you were describing sort of the overview of the paradigms of how conventional medicine looks at thyroid conditions and how a lot of alternative and functional medicine practitioners look at it, and how you look at it. Similarly, there's this other layer to what you're describing at the mitochondrial level, where there's another parallel of what's going on, where when I started talking about mitochondria 10 years ago, it was a strange thing to be doing. And I would get a lot of funny looks, and I was saying, mitochondria are really important to this energy and fatigue story, and everybody else was focused on adrenal fatigue and thought I was crazy. Now mitochondria are in vogue and everybody's talking about mitochondria. But there is what I would say, and I think you'd agree, that there's a very simplistic frame and understanding about mitochondria. And most functional medicine practitioners basically approach it by saying, they run some tests, and we don't even really have very good tests for mitochondrial function, but they run some tests, maybe organic acids tests, or maybe a few other things that indirectly might indicate mitochondrial function or deficiencies of certain nutrients and cofactors needed for mitochondrial energy production. And based on that, they'll say, oh, you have mitochondrial dysfunction. Here, take this acetyl L-carnitine and D-ribose and alpha lipoic acid and CoQ10 and PQQ, and boom, now we're solving your mitochondrial dysfunction. And what you are talking about is something considerably more sophisticated than that. So describe the difference between what your approach is to understanding and fixing mitochondrial function versus the one I just presented.
Well, I think the big argument that is made when we look at tests, like organic acid tests and other tests, or somebody says you have mitochondrial dysfunction. But anybody who's got chronic illness, I think I'll make the argument or the agreement that yes, there's changes in your mitochondrial function that don't make you feel awesome. But after that, I have a real issue, because what somebody would say is, okay, what you have is, if you have your mitochondria is not working good, therefore it's broken. And therefore the primary reason it's broken is because it doesn't have enough micronutrients. So I'm going to give you B12, CoQ10, blah, 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 blah. And my argument would be, first of all, if you have that many micronutrient deficiencies, then the issue is probably not that you need a mitochondrial supplement. What you need is better diet, better digestion, better gut function and physiology, better assimilation of those things, not just more stuff, right? So that's problem A. If you have that many micronutrient deficiencies, then you got to start with why? Why am I so deficient in nutrients? So that's part one. And then, but that also goes to why I might have mitochondrial downregulation in the first place, right? Because maybe I have this chronic dysbiosis. Maybe I have a leaky gut. Maybe I have a dysregulated immune system. All these dangerous things are going on. The second part of that is we make the assumption that the cell has no control. And then if I just give enough stuff with the will of the Jedi, it is going to go into the cell and it's going to work the way I want it to. And that's, listen, I would love if that happened. But how many times I told my kid to go clean the room and they didn't do it? I mean, and you expect me to get them supplement I'm giving you to work the way I want it to, right? I have almost no control of my kids at times, and yet I have more control of them than I have what I give you as a supplement, right? The other problem that goes on is we make assumptions like that, sometimes based on labs that aren't well validated in what they're really measuring or showing. And when you really do look at mitochondrial, when somebody's got reduced mitochondrial function, like CoQ10 comes up all the time. But if you look at the literature and research, CoQ10 is often not deficient when somebody has downregulated mitochondria. Why? Because they're not using it, because the mitochondria is not using the same load of CoQ10. So they don't have sufficient deficient levels. You'll hear that with people where they have hypothyroidism, so they're going to have low CoQ10. No, when you have downregulation of T3 in the cell, you actually have more CoQ10 because they can't use it efficiently. So they don't need more. They need to, the better thing we need to do is step back and say, why is the cell working like this? Ultimately, could there be some mitochondrial dysfunction? Yeah, we can make that argument and talk about things that may cause the mitochondria to truly be dysfunctional. But I don't think it's just as simple as just give B6, B12. I think we do that too often with stuff. And I think it's one of the problems, the same thing we do with thyroid physiology. Well, I don't like that number, so let me give you more of that and that'll make it work. Well, no. It also assumes that the cell has no control, right? Like the cell does not get to be able to control what's going on inside it. And I think we do have enough literature that suggests that the cells actually get to control what happens inside. There's a level of intelligence that we don't fully understand, but cells get to determine what crosses the membrane, what gets into the mitochondria, what doesn't go into the mitochondria. So I think it's a very naive approach when we consider it, it's as simple as that. My argument is, if we think that the mitochondria is damaged or dysfunctional, then we should ask the question, why? And honestly, when I look at mitochondrial tests, you can look at organic acid, but one of the tests I really like to run is a test, if I'm looking at mitochondria, is the MitoSwab Plus from, I can't think of Shree's lab name. Oh, I'm messing
Yeah,
up.
but the test is called MitoSwab.
Yeah, it's called a MitoSwab or MitoSwab Plus. And essentially it's a swab. You look at mitochondria, so we can see mitochondrial density, and we can see how well complex 1, 2, 3, and 4 work. And some of the strategies that when people have done a strategy and I'm like, okay, well, let's see how it works. And we look at their mitochondria is not working any better because it's the wrong strategy. And even when it comes to thyroid physiology, what I'll see is people on higher levels of mitochondria are on thyroid support that are given by their physicians. They don't have better mitochondrial capacity and function. But what they often have is higher mitochondrial density and more oxidative stress, because you're pushing the thyroid hormone will increase mitochondrial density, but now you're creating more mitochondria. The cell, as part of the defense missing, was trying to reduce the mitochondrial density, the fewer mitochondria. Now, with potentially less resources coming into the cell, it's a recipe for more oxidative stress and damage, which I've seen over the years.
I want to stress to everybody listening the importance of understanding paradigm, understanding one's frame, one's lens, or the way that they understand what the problem is. As an example of this, one might understand depression and say, one might look at depression and say, oh, this is a chemical imbalance in the brain. You've got a deficiency of this neurotransmitter, too much of that neurotransmitter. And this has arisen just for random reasons or due to one's personal genetics. And because of this random imbalance of neurotransmitters in the brain, here's this chemical that will interrupt the way that these nerves function so that you produce more of this chemical, or so that we prevent the reuptake of this chemical. So in other words, the paradigm is depression is the result of a randomly or genetically developed chemical imbalance in the brain that requires a drug intervention to fix it. Mm-hmm. Alternatively, I would argue a much more sophisticated and science-based understanding of depression would see depression as a very natural and normal result of a person being out of harmony in some way, being not aligned with either eating healthy, living healthy. And we know, of course, that nutrition impacts brain function and mood and depression. We know, of course, that exercise impacts it. We know sleep and circadian rhythm impacts it. We know light impacts it. We know toxins and inflammations and gut health impacts it, right? So we start to see all these layers emerge. We know that social connection impacts it. We know that we have all of these layers. Oh, like also how aligned you are with, you know, if you're working a soul-sucking job that you're not passionate about, and that's how you're spending your days, like it's pretty reasonable to be depressed. Whereas if you're spending your days doing something you love and you're passionate about, you probably are going to be in a different mood. And we know that all of these dimensions, we have lots and lots of literature showing all of these dimensions impacting on brain function, mood, and neurotransmitter balance, and ultimately this whether you are depressed or a happier person. And in light of all of that knowledge, it's actually ridiculous, absurd, and totally unscientific to myopically reduce depression down into just a random chemical imbalance in the brain. And this is just our unintelligent body doing this for random reasons. Here's this drug to fix your chemical imbalance.
Yeah.
And so what you're talking about is essentially the same thing at the level of the body. You have a lot of people who are in a rush to do chemical interventions and treat the body as unintelligent. And what you are arguing in favor of is seeing the body through a lens that says, why is the intelligent body doing this and responding in this way? And that totally changes the types of interventions that you will do, the types of approaches you'll use to try to fix that.
Yeah, well, and I think based on what you said, we'd say, hey, if you have better gut physiology, you have probably better neurotransmitter function. Okay, so I potentially have compromised neurotransmitter function. Okay, well then, what are the things that can influence it? Well, your gut. Well, maybe we should take a look at it. Forget about that. Let's just give you this drug. Let's just bypass the thing. Yeah. But we do that with everything. We know exercise increases mood, increases dopamine levels, right? It makes us feel good, increase serotonin, makes us feel well. But I'm depressed. Do you exercise? No. Well, maybe the issue isn't that you need a drug. Maybe the issue is you need to do the things that are going to create that positive environment. You may be doing a lot of things or have a lot of things going on in your environment that are creating it's still, in my opinion, it's still an appropriate response, at least at the onset, right? If you have a bad gut, the appropriate response might be, whoa, I've got an infection. I need to move serotonin away from, or move tryptophan away from making serotonin and drive it down the quinolinic acid pathway and make some maybe things that can be used as more toxin to deal with this organism or this threat, right? Feeling stressed. Oh, I have insomnia. Well, maybe the reason you have insomnia is because you have this stress response going on. Your body's like, whoa, we're in danger. We don't need to take a deep sleep. I don't really need that level of melatonin. I really need my body to be more alert. So I'm going to drive that tryptophan away from serotonin and make more neurostimulatory chemicals. So, I think sometimes we just assume that the intelligence isn't working. I think it is working, but it's responding or adapting to whatever is going on in that environment. So that's where we have to ask, what's going on in your environment that's creating this to manifest? So but that's hard, right? That takes more than 5 or 10 or 15-minute visit every couple months or a couple times a year. And it doesn't leave us too much room to not take care of ourselves, right? I mean, the other model allows it to be like it's an external thing. It's a disease or disorder. I'm not in control. It just happened to me. And the model that we're talking about is more where somebody has to say, not my fault. It's not fully my fault. There's a lot of things that could have happened, but it is my responsibility to make the change. And I think that's the really important part. I think some people hear the message like, oh, you tell me I did it. It's my diet did this or whatever. Not necessarily your fault, but it is your responsibility once you're educated that you have to take care of yourself. You just can't throw the cash on the dashboard and say, take me wherever and expect that you're going to get to where you want. You have to plan the strategy if you want to be healthy and be functional. And most people aren't. They're not worried about their health and their well-being until they're in a state of chronic illness and disease, unfortunately.
So let's get practical. Let's say a person listening to this, and probably most people are, who are listening to this or in this category, are in defense mode to some extent, have symptoms, whether those symptoms are hypothyroidism or brain fog or depression or chronic fatigue or whatever else. We can see them through this paradigm as a reflection, as part of the intelligent body's adaptive response to being chronically overwhelmed by these stressors, danger signals.
Right.
How do we get the body unstuck? How do we get it out of danger mode and put it back in energy mode where the mitochondria are switched back online and are functioning optimally?
I wish it was sexy, Ari. I wish it was.
Make it sexy. Make it sexy.
But it comes back to, I think, number one, and shameless plug. Kelly Halderman and I wrote a book called The Thyroid Debacle, and this is what, in the third part of our book, we don't have any supplement recommendations. No, lifestyle and diet and all the things that aren't sexy. But if you really want to start to recover your health, you've got to take a look at what I talk about called your fitness factors. And those are the things that are really influence how your body is. Is it in manufacturing mode or is it in cell defense mode? So you look at your emotional fitness, like what's going on in my life? What's going on between the 6 inches of my ears? Like, what am I thinking about? What am I focusing on? If I'm in worry mode all the time about something in the past or something in the future, you're not living in the present, and that creates stress. So what is your emotional fitness? And then once you and for my clients, I give them a scale of 0 to 10. I ask them, like, each of these fitness factors, give yourself a scale of 0 to 10 and rate yourself. And we'll look at emotional fitness, physical fitness, metabolic fitness. That's how the chemistry of the body's working. We'll look at dietary fitness, sleep fitness, respiratory fitness. We'll look at your habitual fitness. What are the things you do day in, day out? Things you may realize and things you don't realize you do every day. And when we put all those pieces together, for what most of my clients, we just start with, okay, well, this is the weakest one. Your sleep is terrible. Now you scored that the worst. Let's look at your habits and behaviors that center around sleep, and let's start there. And we start there. Now, while they're working on those things, I'm also looking at their chemistry and what can I use dietarily and nutritionally to kind of tweak some of those systems. That's the crux of how I get my clients well. And people say, well, you're the thyroid specialist, which thyroid hormone? Listen, I typically, I'm getting people off of thyroid medication. The stuff they're taking is not converting well. They've got mixed in this belief that they can just whack-a-mole it with P3, 4, 2, 1, whatever, and it's going to work. And they after months or years, they realize it doesn't work and they actually feel worse. And so it's not sexy, but if you have to look with an objective lens, and most times we need a third party to actually help us look objectively at what's going on. And we have to say, this is an area that you feel is a problem. It looks like it's a problem. Now, what can we do incrementally to start making changes to bring your level of fitness up in this category? If we think about it from a physical fitness perspective, I don't lift, I don't run, I can't do anything. I can't. Okay, can you walk 5 minutes? No, great. Let's walk 4. Okay, I can do that. Great. Now we started, and now we have a building block. Do you need strength training? No, I can't do it. What can't you do? I can't do anything. Can you get out of a chair? Well, yeah, I can get out of a chair. Okay, can you do that 3 times in a row? Yes. Great. Now we're doing some physical fitness, but we'll give them a physical fitness test in the beginning. From an environmental standpoint, what's your toxic load around in your environment? Like, what are your personal products? What's your sleep? What are your cleaning products, right? What's your electronic stress that's going on, right? And look at the things that we can do to reduce things that are stressful on the physiology and do things that can raise them up that fitness scale. None of it's sexy, but if you want to be healthy and stay well, the solution rarely comes in a bottle, and it's not attractive and people who make supplements and recommend them, I recommend them too, but they're not a long-term strategy. They are a short-term strategy to help us get to the next level. But ultimately, if we want to get somebody out of cell stress response and get them back into healing physiology, we have to identify the stressors, reduce or eliminate them to as great a degree as possible, and then support the recovery of those tissues back to normal function and physiology. And when you do that, it miraculously, people start to feel and function better. I mean, crazy, without a lot of drugs, without lifetime of supplementation. It's these fundamental things, but a lot of people don't want to do those things, or they're not aware that the things that they're doing could potentially cause them to be unhealthy.